Hello everyone, for this playlist we are going to deal with completing the square. I am going to explain you step by step on how to complete the square and write in this form right here, y equals a x minus h power 2 plus k. And from there, we're going to find the vertex, we're going to find the axis of symmetry, x and y intercepts, and we are going to sketch the graph. For example or exercise number 1, we have, so let's first do part A, which is the completing the square, and rewrite this function in this format right here, okay? So let's start. The first step that we're going to apply here is that we're going to let the terms with x, meaning x squared and negative 6x, by itself in the right side. That means that we're going to move the 4 into the other side for now, but then we're gonna have to move it back, okay? So let's just move it now. So it's positive, so we do the opposite, which is negative. And we're going to have y minus 4 equals x squared minus 6x. Now, why is it called completing the square? Because we are going to add some numbers into the right side and also the left side. That means that we're going to add some number here, and also we're going to add some number into the left side as well. It has to be the same number, okay? So one number is gonna go here in order to complete the square. So to find this number is going to be, remember, right, that this function, right, is in the form of y equals ax squared plus bx plus c, right? So our b value, which is the one that we're going to be using to find the missing number, is in front of the x. So we're going to grab it and we're going to divide it by 2, and then we're going to do a power 2 of that number. So in this case, our b value is negative 6. So we're going to get minus 6, and we're going to divide it by 2. Remember, it's always the number in front of x divided by 2. Okay, this 2 is part of the formula. And then we power 2 that number. So negative 6 divided by 2, we're going to get negative 3. And then we power 2 the number. So negative 3 to the power 2 means negative 3 multiplied by negative 3 again. That gives us positive 9. That means that we're going to add into both sides a 9 in here, and also a 9 in there. Okay? Let's rewrite the equation. So we have 9 plus y minus 4 equals x squared minus 6x plus 9. Let's combine like terms here on the left side, okay? We have 9 and negative 4. When we combine those two numbers, we're gonna get a positive 5, right? So we're gonna end it up with 5 plus y. Now let's take a look at here. This portion of the function is always gonna be a perfect square solution. What does that mean? That means that this is always gonna be in this format, right? Like that. Some x and then to the power of 2, okay? It's always gonna be in this format. But one number is gonna go here. It's very easy and straightforward. Just take a look of our number that we get, which is 9. Let's go back one step before our final answer. The number that is inside of the parentheses with the power 2. That number is always gonna go in the perfect square solution. So in this case, it's -3, so we write down -3. So it's always the number inside the parentheses, okay? Before our final answer. The next step that we're gonna do is that we're gonna move the 5 into the other side in order to let the y by itself, okay? So let's do that. So it's +5. So we do -5 and -5 to both sides. This cancels. And we are left with y equals x minus 3 to the power 2 minus 5. Okay, now it's written in this form right here. Our a is the number in front of the parentheses, which automatically is 1. Our h value is a 3. Our k value is a -5. So that's part A. Okay, let's put part A there. Now let's do part B. Part B is to find the vertex having this format of the function. The vertex is pretty straightforward. It's h, comma, k. Okay? Our h value is going to be 3, comma, and k will be the number outside of the parentheses. In this case is -5. In other words, our vertex are going to be the numbers that appear in the function, except these two right here, that is an exponent. So let's just focus on these two numbers. The h value is going to be the opposite of whatever is inside. Notice that it's -3. So when you put it as a vertex, it's going to be the opposite, which is +3. That k will always remain the same. It's -5, so just bring it down. Now let's go and work on part C. Determine the axis of symmetry. The axis of symmetry is really straightforward. It's going to be a function as well, or an equation, which is x equals to h value of the vertex. Notice that our vertex, right, is 3 and -5. Therefore, our axis of symmetry is x equals the h value, or in this case, the x value of this point, which is simply 3. Now, let's work on part D of our problem. Determine x and y intercept. Let's find our x-intercept first. So to find the x-intercept, we need to let y equals 0 from our function or equation, okay? Remember, our equation from part A, after completing the square, was, so we're going to let y equals 0 and solve for x. That way, we're gonna get our x-intercept. So let's start. We let y equals 0, leave the x by itself like that, because we're gonna solve for it, and bring down -5. Now, to solve for x, notice that we have in parentheses power 2. So let's first move down -5 into the other side. So we could let by itself this term right here with the power 2. So it's gonna be, so it's -5, so it's gonna be +5, +5. So this cancels. So we're left with 5 here equals x minus 3 to the power of 2. Now, we need to somehow get rid of this power 2 right here. And how do we get rid of a power 2? Simply by squaring root both sides. Because our power is 2, our index should be 2 as well, both sides. And don't forget, this step is very important. The number, when we square root the number, we have to add a plus or minus to the number, okay? Having said that, so the square root with the power 2 or exponent 2 is gone. So in the right side, we are left with x minus 3, and in the left side, we are left with positive or minus square root of 5. Let's leave the square root of 5 as it is, okay, for now. The next step that we're going to do is that we're going to solve for x. So all we have to do is to move the negative 3 to the other side. So it's negative 3, so we move it with positive 3 both sides. Let's follow here. So this cancels, so we're going to left with x equals a positive 3 and then plus or minus the square root of 5. Do not combine these two for now, okay? Because this one has plus or minus. So we're going to have 3 plus or minus square root of 5. That means that we're going to have one solution with a plus sign and another solution with a minus sign. So we're going to have actually two x-intercepts. One intercept is going to be 3 plus square root of 5, which if we enter this into the calculator, we're going to get approximately 5.2. And our other solution is 3 minus the square root of 5. When we enter this into the calculator, we're going to get approximately 0.8. So that means that our two x-intercepts are going to be 5.2, 0, because remember we let y equal 0, and the other point is 0.8 for x and 0 for y again. Now let's find the y-intercepts. Let's see how many can we find. Sometimes only one, sometimes two, and sometimes none. That means that our graph will not pass through our y-axis, okay? So let's rewrite the equation. Our equation, remember, it's y equals x minus 3 power 2 minus 5. Remember, to find x-intercept, we need to let the y equal 0. Now, to find y-intercept, we need to let x equal 0. So let's do that. So let's rewrite y, because that's what we're trying to find. And let's plug in 0 for x. So we're going to have 0 minus 3 power 2 minus 5. That leaves us with 0 minus 3, that is negative 3 power 2 minus 5. Remember that we need to work on our exponent first. That will leave us with negative 3 power 2, that is 9, minus 5, that is 4. So notice that we only have one y-intercept. That means that our point will be 0 for x and 4 for y. So this is going to be our y-intercept. So we already have 1, 2, 3, 4 points to sketch the graph. So let's do it. So the points that we have found are from the vertex, which is 3, negative 5, our x-intercepts that we found right here, which is 5.2, 0. Our next point will be 0.8, 0. And from our y-intercept, we found 0, 4. Let's sketch the graph. Let me try my best to do our graph, okay? Negative. So remember, these are negatives, positive. This is our x-axis. This is our y-axis. Now, let's just plot the points. Let's do our vertex. Remember that our equation of function is this one, right? Notice that the number in front of our parentheses automatically is 1, is positive 1. That means that our graph is gonna sketch upward, okay? So we already know how the graph is gonna look, okay? This number in front of the parentheses give us a hint on how the graph is gonna look. So our first point, which is the vertex, is 3 for x. So we go 3 here, and -5 for y. So we go -5 to the bottom, right? Because that's where it's -5 is. So it's approximately there, -5 for y and 3 for x. So we know that it's gonna look something like this. Let's plot that next point. It's 5.2. Notice that it's not exactly 5, so we're gonna eyeball it. So 5.2 is a little bit more than 5. So, and it's 0 for y, so it's right on the x-axis. So let's say it's right there. Our next point is 0.8. It's almost 1. So that means it's a little bit to the left of the 1. And y for 0, so it's about here. And our last point that we need in order to sketch the graph is 0,4. So 0 for x and 4 for y. We already have some good points, so we just connect it and make it like a parabola style. So it's gonna look like this. It's not perfect, so it's kind of a sketch, but it's good enough. Now, your professor sometimes will ask you to graph the axis of symmetry. Remember that our axis of symmetry is x equals 3. When we graph that, it's always a dotted line that is passing through our vertex, okay? This case is x equals 3, so it has to pass to the 3 and to the point of the vertex, which is that one. Okay, so that's our axis of symmetry. And that's it. Thank you for watching.